So today in Kubernetes, let's talk about pods, and then we can see about deployments, and then we can see namespaces, and then we can see services. Okay, so these are like very important um, things in Kubernetes, because most of the time we will be working with pods, like we will be troubleshooting these pods, and then we will be doing the deployments for different versions, and then we will be working with the different namespaces, because different teams will have different namespaces, and then we will be working with services, because this helps in connecting different pods. Okay, so now let's see what exactly is pod. So pod is the smallest unit in our Kubernetes cluster. So it is a running instance of an application. So in case if you are running a pod, it will be running an application, and it will be like serving the data to the users. Okay. So let's check. So this is deployment. Okay. So let's consider this as deployment. So deployment is the um, thing. So inside deployment, actually we will have replication sets. Okay. So replication set or replica set, both are same. So we will have replica set, and then inside replica set we will have pods. Okay, so we will have different pods, like based on the number of replicas. In case if we are keeping replicas as 3, then we will have 3 pods running. Okay, so this is pod 1, pod 2, pod 3. So when we create a deployment, so we will be mentioning the replica set inside the deployment, like what should be the maximum number of pods that should be running at the given number of time. So this replica set will take care that the given number of pods will be always running. So in case we have 3 pods, so all the 3 pods it will be serving the data. Okay, so these 3 pods, for example, if any of the user is trying to access the data, okay, so you will this pod will be serving the data. Okay, in case if due to some issue if this pod gets crashed, then second pod will try to serve the data for the user. Similarly, meanwhile, when the second pod is running, this deployment it will try to bring up this pod again. Okay, so that we will get the new pod again. It will Pod 1 will be created. But what happens, the main issue is that in case, for example, if this pod has an IP of for example, let's consider 172.1.1.1, and then this pod has an IP of 171.1.1.2, and this is of 171.1.1.3. Then in case if this pod gets deleted initially, then the new pod which is created, it will have the IP address like 172.1.1.4. It will not have 1 again. Okay, it will have a different IP. But this user who is trying to access, previously he was accessing this 172.1.1.1, right? But how we knows like this, how we knows this new pod, because it has got new IP, right? 172.1.1.4. How we knows? Because these things are managed using service. Okay, so this service will have all the information of these parts. Okay, it will have information of all these parts. So in case if any new part is created or deleted or modified, all those things will be uh, known to service, and service will take care in transferring the data to the request based on these parts availability. Okay, so if you see, to run a pod, we have to do kubectl run, and then we have to give the name, and then we have to give the image, and then we can define the port, like on which port number it has to be accessible. Okay, so we have the EC2 instance. Let's clear kubectl get pods. So we have one pod running. Let's try to delete that one. So we have deleted. So in case if we have to create a new pod, we have to give kubectl run. Okay, run, and then we have to give the name. For example, if we take this one here, the name is Nginx. Okay, so let me try to run that one. So now let's check whether we have any parts. Okay, now we don't have any parts. Okay, so, so now let's try to run this one. So we got the pod kubectl get pods. So we have Nginx. Okay, so how we can see we just got the name and then state. The state is one per one. So what is this? This is like number of containers available, and this is number of containers ready. Okay. For example, in if any of the pod. Okay. So for example, if any of the pod has, so actually pod, this pod, so inside pod we will have container. Okay, container. So for example, in case if we have two containers like c1 c2, then that ready status, we have seen the ready status, right? Actually it will be 2 per 2 in case if it is running. So for example, if one of the pod is having some issue, one of the container is having some issue, then it will be like 1 bar 2, then this application it will not run. Okay, always it should be 2 bar 2. Okay, in case if it has two containers, but the application which we have seen here, so actually it has only one container, so it is, and it is running. Okay, that's why it is 1 by 1. And then we have something for showing the status, that is running. Okay, and then age, like from how long it is running, so we can see that one. So now let's see kubectl get parts hyphen o wide wide. Okay, when you do this one, you get the IP address. So here if you see, we don't have the IP address of this part, right? If you see it, now we have the IP address. Okay, and then node is minikube. Okay, now let me try to create one more pod. Okay, now previously I have given the name as Nginx. Okay, that's why if you see here, name has come as Nginx. Okay, now let me try to change this to some other thing. For example, I will give it as orange. Okay, so if I run is, now let me check the parts. Okay, so we have one pod as Nginx and one pod as orange. Okay, now when we do hyphen o wide, okay, kubectl get parts hyphen o wide, if you see here, this one has different IP and this one has different IP. This is 23 and this is 24. Okay, also now I have given this as orange. uh, like you have to know like what is the image used here. Okay, because you have created, so you know the image. For example, if some other team have created the this pod, okay, but you have to know like what is the image name. Then what you can do, kubectl describe. Okay, kubectl describe pod. You have to describe the pod, right? We are checking pod. Okay, so kubectl describe pod, and then which pod you have to check? You have to check orange, correct, right? So just write that one. When you do this one, if you see here, pulling image Nginx. Okay, so by seeing here we will know like what is the image it has pulled. Okay, so this and all like very important when troubleshooting the things. So first thing is you have to do describe. Okay, and then for example there is some error. Okay, there is some error in your pod, and then you have to check the error. Okay, then how you can check? Then you can check using kubectl logs. Okay, kubectl logs, and then for which pod you have to check, you know, no need of giving pod here, you can just give orange. Okay, if you click here, if you see, we are able to see the logs. Okay, in case of any error, you can come here and you will be able to see the logs, so that you will be able to troubleshoot the issue based on the things. Okay, if you see here, here also it is showing which image it is using and which version, like it is 1.27.2. Okay, this is how parts works. Okay, now kubectl delete pod orange. So in case if you do kubectl delete pod, you have to give pod. Okay, because we are deleting the pod, right? And what is the name of the pod? Orange. So when we delete, this is deleted. Now we will have only one image. Kubectl get pods. So we have only one image. So we have created using command, and then we can create this pod using YAML file as well. Okay. So in case if you have to get any YAML files or something, you can just come here and then you can just type Kubernetes pod YAML. Okay. So you will get the sample YAML file. You can just copy this one and based on your requirement you can modify. Okay. So I have copied this one. Now let's go to the here. Okay. Now I will create a directory mkdir demo. Okay. I will cd into demo. So here we don't have anything. I will use vi editor. So I will give pod.yaml. Okay. Now enter, and then just I will do I for insert and then paste. Okay. Now we have the pod YAML file. So here what we have the API version. This is the version which we have to give, and then kind. Okay, kind is pod, and then metadata. Metadata is nothing but we will be providing some variables. So here we have given the name as Nginx. In case if you have to modify, for example, I don't want the name of that part to be Nginx, I have to give it something else. For example, I have to give it as Apple. Okay, and then in the spec, so as we have seen here, so we will have deployment. Inside deployment, we will have replica set, and we have inside replica. It will create parts. Inside part, what we'll have? We will have the containers. Okay, so we have to provide the container details. So if we come here, we will be providing the container details. Okay, containers, and then what is the name of that container? Container name is Nginx, and then image name. We will be using the image, right, in container, so we have to give the image name, and on which port it has to be accessed, on port number 80. Okay, so we given these details, just do wq exclamatory mark, so it is saved. And then in case if we have to run the pod, we have to do kubectl apply. Okay, kubectl apply -f. Okay, -f, we have to give the file name pod.yaml. When I enter, okay. Actually, I have given it in capital letters, so actually we shouldn't give it in capital letter. We have to give the name in small letters. Okay. So let me try to edit that one. Okay. Now let me try to run. Kubectl apply -f pod.yaml. Okay. It didn't edit properly. So if you see here, actually that it changed here. Okay. So it shouldn't be like this. Why it is not going? Okay. API version is v1. Kind is pod. Okay. It got edited here. Kind is pod, and then name should be with small letter Apple. Okay, let me try to save this one. Okay, now let me try to run the command again. Okay, so the pod Apple is created. Okay, now let me do kubectl get pods. Okay, so we have the pod, and what is the name of the pod? Apple. And then in case if I have to see the IP addresses and all, we have to do kubectl get pods hyphen o hyphen o wide. Okay, so you will get all the details like on which node it is running and the name and the IP address, everything it will come. Okay, and then if in case if you have to see the details, kubectl describe pod. Okay, and then to check the logs, kubectl log, we shouldn't give pod again, kubectl log and then pod name like Apple, so that we'll be able to see these things. Okay, now we have seen the pod. So what is deployment? Okay, let's see what is replica set. Okay, so replica set in Kubernetes ensures that specified number of pods or replicas are running at any given time. So at any given time, okay, in case if we define a replicas equal to 3, it will be always trying to run minimum 3 pods, no matter what. In case if it is crashed, or in case if we are trying to do something, it will always maintain minimum 3 pods. Okay, so how we have to give replicas equal to 3, then we will be able to create 3 pods. Okay, so if you see here, replica set, it will create pods, and then where we define this replica, we will define it in deployment. Okay, now let's see a sample YAML file for deployment. Okay, so I have given it here. So we can come here, Kubernetes deployment YAML. Okay, just come here, click this one, so you will get a sample deployment file. Okay, it is copied. Now let's go here, nano deployment dot YAML, paste. So if you see here, API version, so API version we have given as apps/v1. Okay, and then what is the kind? Kind is deployment. Previously for pod, what we did, for pod we are given as pod. For deployment we are giving it as deployment, and then for this deployment should have a name, right? So that name is nginx deployment. Okay, and then we have given inside this deployment we will be deploying an application, right? So for that application we have given the name as nginx. Okay, and then we are defining under the spec section, we will be defining replicas. So these replicas equal to 3 means we will be creating 3 pods. Okay, and then for example here let's change the name. Okay, it is anyway nginx deployment, right? Okay, let it be. And then match labels. So in case if you have parts which has the label of app equal to nginx, it will be creating those parts in the deployment. Okay, and then this template is there, right? So this template is nothing but parts template. If you see here, if you see here, so we have this spec container everything, right? So if you see here, so we will have the same thing. So all these details are from here. So from metadata, they will just copy it. Okay, they will just copy this metadata and then they will paste it here. So we will have the same details of these parts, because inside deployment we will have replicas, and inside replicas we will have containers. So how it will be? It will be coming as a hierarchy. Okay, let me, so it will be like deployment, and then inside deployment we will have replicas, and then inside replicas we will have the pod. So it will be in a tree like structure. So deployments, replicas, and then pod. Similarly if you see this one, let me, okay, if you see here, we have the deployment. Okay, and then inside deployment, replica, it is like this main line is there, right? This main line is deployments, and the second line is for replica. Okay, the second line is for replica, and then this third line is for pod details. From metadata we will have pod details. So it will be in this layer. This indentation is important because and these things will be common: API version, kind, metadata, and then spec. Okay, and then we will have a separate spec. This spec is for container. Okay, this spec is for deployment. So deployment spec will be in the first line, and parts spec will be in the third line. Okay, so we have copied this one. Now, okay, okay. Now we have created the deployment. Now let's apply kubectl apply -f deployment.ml. Okay, so what it is, deployment apps nginx deployment created. So what is the name of the deployment? Deployment's name is nginx deployment. So when we do kubectl get deployment, okay, when we do kubectl get deployment, we will get nginx deployment. Okay, name of the deployment is nginx deployment. So if we do kubectl get pods, okay, if you see, it has created nginx deployment, and then what is the name of the pod? It has given some random name, and then name of the deployment, name of the deployment, and then it has given some pod. Okay, now let's try to delete these parts which we created earlier. So if you see, we have three parts, and then these three parts are created by deployment. Okay, so this deployment YAML file, it has the replicas as three, so it has created three parts. Okay, and then of this container. Okay, now let's try to change these replicas to 5. Okay, vi deployment.yaml. Okay, now we have kept replicas as, there is some issue with the vi editor. Okay, so now let's consider we want 6 parts. Okay, because there are lots of incoming users and heavy traffic is there, so you want the number of replicas to be more. Okay, now let's define replicas equal to 6. Okay, now again I do kubectl apply -f deployment.yaml, enter. So deployment, previously it was created, now it is configured because it is already created, right? Now let me do kubectl get pods. Okay, now if you see, I have 6 pods. I have 6 pods running because I have set the replicas as 6. That's why we got 6 pods. So based on the requirement, you can set the number of replicas. So in case if you define that replicas in the deployment YAML file, you will be able to create the number of replicas. Okay, so that 6 pods will be serving the data. So in case if the users increase, you can increase these replicas so that it will create any number of pods. But there is a limit, like in case if there is some memory and CPU constraints on nodes, then you need to create new nodes. Okay, okay, so we have seen deployments, and we also know what is pod, and then we have something called namespace. Okay, namespace is nothing but it is an isolation isolation, or um, it is isolating the Kubernetes cluster into separate thing, so that each team, like for example, if you have multiple teams like dev, testing, and infra team, in case if they have to work on a single cluster, we can create separate namespaces so that each team, they will not disturb other teams work. Okay, so we have this namespace. Okay, deployment, sorry, so it is Kubernetes cluster. Okay, so we are dividing it into um, multiple clusters. Okay, so we have this Kubernetes cluster. So we are splitting this Kubernetes cluster into multiple namespaces. Okay, so let's consider we have different teams. Okay, for example, we have one Kubernetes cluster and we want dev team to work on this thing, and then we want testing team to work on this, and then we have some operations team, and then we have one more like a backend dev team. Okay, backend dev team. So all of them they have to work on same cluster. But in case if they are creating some files or something, it shouldn't be disturbed by other team. For example, if they are creating some Nginx application, okay, it shouldn't be accessed by testing team and it shouldn't be accessed by any other team. It should be like isolated. They should have like a separate environment and they will be testing and they will be developing and whatever they want they will be doing. So how it can be achieved? It can be achieved using namespaces. So namespaces are in isolation in the Kubernetes cluster. Uh, it can be like converting a physical cluster into a virtual clusters. Okay, so they will be allocated with resources so that they can be using their own resources, and it is like efficient management of the cluster. So we can, by using the namespaces, we will be efficiently managing the cluster because multiple teams will be working and will be reducing the costs as well. Okay, now let's see how to do that one. Now let's do kubectl get namespace. Namespace shortcut is ns. You can do this one, or else you can do kubectl get namespace. So always if you want to type this entire thing, you can type, but there is a shortcut called ns. So both will give the same result. Okay. So by default we have okay, this is we have created yesterday. Apart from that, we have four namespaces. These are default namespaces, and in case if you are not providing namespace and if you are creating something, by default it will create on the default namespace. So whatever parts we created before, those are created on default namespace. So kubectl get parts. Okay, so it is created on the default namespace. For default namespace, no need of mentioning any namespaces. But okay, in case if you have to see some parts which are in this namespace, for example in DevOps namespace, kubectl get pods. Okay, hyphen n, we have to give hyphen n. Hyphen n is nothing but for referring to namespace. Okay, in which namespace we have to see? We have to see in separate namespace. Okay, so we have two parts here. Okay, those are belongs to DevOps namespace. Now how to create a namespace? We can use kubectl, okay, create, and then namespace ns namespace. We can give it as test. Okay, so namespace is created. So how to view the namespace? Kubectl get ns. Okay, so test is created. So now we have to check like how many parts are there in the test namespace. Okay, kubectl get parts hyphen n, and then which namespace we have to test. So in test namespace, no resources found. Okay. Okay, now we have to create the pod. Okay, if you see here, we have this pod.yaml. Okay, but when we run this one, it will try to create the pod in default namespace. But we want this pod.yaml to be creating pod in which namespace? In test namespace. So what we can do? So in case if you want that to be created in test namespace, we have to come to this metadata. Okay, under name. Okay, under name, enter, you give namespace. Okay, namespace colon, and in which namespace it has to create? test. Okay, that's it. Now you can save. Okay, now let me apply this one. kubectl apply -f pod.yaml, enter. So pod.yaml is created. Let's see. What is the pod name? Apple. Now let's try to check the pod. kubectl get pod in default pods. Okay. If you check in default pods, we don't have the pod named Apple. Correct, right? Now let's do kubectl get pods -n in which namespace we have created test. Okay. In previously when we checked in test we didn't add any resources, right? Now when we do enter, we have the Apple pod running. Okay. What we have changed? We have given the namespace under metadata. Okay. Now let's do deployment.yaml. Okay, let's use nano. Okay, so if you see here, we have given the replicas as 6. Let's change it to 2. Okay, and then under metadata, we have given the name as nginx deployment, and then we can enter. We can give the namespace. Okay, and which namespace we have to create? Test. Okay, what will be the name of the pod? Pod name will be nginx deployment, and it will get a random name. And what is the name of the deployment? Nginx deployment. Okay, now let's save this one. Okay, now let's check the deployment in test pod. So to check the deployment, kubectl get deploy -n test. Okay, so no resources found. Okay, means deployment files. Okay, now again let's apply kubectl apply -f deployment.yaml. Okay, if you see here, deployment is created. Okay, now again let's try to execute kubectl get deploy. Okay, so if you see here, we have the deployment ready. Okay, and then how many parts? 2 out of 2. Okay, now let's do kubectl get deploy get parts -n test. So if you see here, 2 parts from the deployment is created. So by this way, we will be able to create these deployments in the namespaces. So what is the use of deployment? So the main use of deployment is, for example, we have an application like Nginx, okay, and then we have to deploy it in prod, okay. So in case if you are deploying something in prod, it should be accessible to the end user 24/7. So always it should be accessible. It shouldn't go down. So in prod, we will be deploying it as a deployment. Okay. When we deploy it as a deployment, so minimum we should have 2 parts always. Okay. Like part 1 and part 2. So part 1 will be serving data. In case if it crashes, part 2 will serve the data. Meanwhile, it will try to recover the part 1. Okay. In case if we have Nginx version 1, now we got some new version like Nginx version 2. If we have to deploy this one, it will not go down. Initially it will try to deploy the version 2 here. Okay, it will become Nginx version 2, and this pod will be serving data. So it will do the rolling update. So once version 2 is updated, then this will bring this one down, and then it will update the version 2. So version 2 will be available. So uh, deployment will help in doing the rolling update. Okay, so that the parts will be always available and always it will be serving the data. And then we can define the number of replicas, like how many number of parts are required for serving particular data. So those things will be served by deployments. Okay, and then we have seen namespaces, we have seen deployments, and we have seen replica set. Now let's see services. Okay, now as we seen earlier, we have this deployment, and then we will have like pods inside it. So means we will have the replica set, and then inside replica set we will have the pods. Okay, so in case if a particular pod, if one of the pod gets deleted, so so we have pod 1, and then we have pod 2, and then we have pod 3. Okay, so for example, due to some issue this pod 1 got deleted. Okay, so as I told earlier, it will have unique IP. So if this pod is deleted, this deployment, okay, this deployment will have replica set, right? So what is the use of replica set? It has to maintain three pods, three pods all the time. So all the time it has to maintain three pods. That is the main use of replica set. So in case if pod 1 dies, then what it will do? It will try to create the new pod. Like again, it will try to create P1. Okay, but the IP address, for example, before it was like 1.1.1.1, and this is 1.1.1.2, 1.1.1.3. The new pod which is created, it will be like 1.1.1.4. And then the user who is trying to access, he will be previously accessing this 1.1.1.1 in, and then the data is served from here. In case if the new part is created and if data has to be served from here, how will that user know like this the data is coming from this part and I have to access this one? So it will, the end user will not know, and it will automatically taken care by service. Okay, so what this service does, this service will create a new pod. It will have the data, like it will have the data of each pod created and deleted. So it will know like this P1 is deleted with this IP, and this P1 is added, this P1 is added with a different IP. So it will manage, and this service will be sending the data. So when the end user tries to contact these pods, you will not be directly contacting pod. Okay, you will be directly contacting the service, and service will transfer the data to different pods. Okay, this is how the service will work. Okay, so in services actually we have three types. Okay, one is cluster IP. By default, this will be the default IP address, like default service that will be used. So this cluster IP, it will be like only used for internal communication. Okay, so it will not be accessible by outside. For example, we have these parts. So if this part 1 has to communicate with part 2 and part 2 has to communicate with part 3, then we can use this service, that is cluster IP service. Okay, cluster IP. Okay, but for example, we have this pod and we have to access it from our system from outside. Then we cannot use this cluster IP. Okay, then we have to use something called node port. Okay, then we have to use something called node port. So for node port, by default the port number, so if you see here, we are, this is the cluster IP is the default. So how we can differentiate? Previously we have seen for pod it will be pod, and then for deployment it will be deployment. This is service, right? So for service it will be service, and then name my service. And then here we will be defining ports, because in case if we have to access these ports, we have to define the ports. Here we are defining port as 80, and then target port is 8080. So target port is nothing but the port which we assign to the um, application. Okay, and then we have node port. Okay, node port we have range from 30,000 to 32,767. So this is the range in which we will have the node ports. Okay, in case if we have to access these ports outside, for example, we have a pod. Okay, we have a pod inside, this is cluster. Okay, So in case if it has to talk with another pod, we can use the cluster IP. So it will not be accessible outside. Okay, we have this cluster, and then we have our laptop. Okay, we have our laptop, and then we have to access this pod outside. Okay, then we have to do, then we have to use node port. Okay, so by default it will be having the port in the range. So it will, this cluster will be assigned with port 30,000 to 32,767. Okay, in this range we have to give the port number. Okay, and then we have this pod. So this pod will have one port number. Okay, and then we will have one more service. So that service will have one port number. Okay, so this target port is for pod. If you see here, we are using node port, right? So previously we are using cluster IP. So how we can define whether, how we know whether it is cluster IP or node port? So we have defined type. Okay, type is cluster IP. Okay, and then for node port, similarly, type is node port, and then we have given the node port range as 3007. So it can be in the range of 30,000 to 32,767. Anything can be there. So here port, this port is like port of the container, target port is port of the service, and then node port is port of the cluster. Okay, so here we can define which type of port we need to access, and then we have something called load balancer. So this load balancer mostly we will be using along with our cloud applications. So here we have to define as load balancer, and then we have to give the port and target port. Okay, now let's try to create this one. So just we have to copy this one. So here nothing like API version, kind, metadata, spec. This is common for everything. Okay, so here we are creating a service, and then this service is of cluster IP. Cluster IP means for internal communication. Node port is for external communication. Okay, now we, okay, nano cluster service.yaml. Control X, Y. So if you see here, service, my service is created. Okay, now let's see whether service is created or not. So to see the service, we have to use kubectl get service. Service short form is SVC. Okay, if you see here, my service is created. Okay, so how it got my service? We have defined the name under metadata. Let's vi cluster service. If you see here, I have given the name as my service. Because of that, it has created the service as my service. Okay, now uh, this is cluster IP. Okay, it will not be accessible outside. Now we can create a node port. Okay, so in node port we will have three ports. Okay, and then type is node port. We have to give this as node port so that it will be accessible from outside. So let's copy this one and then just paste it. So this IP no need to be only 3007. We can be like 3000, 30,009 or else 30,012, whatever it is. But it has to be in the range of 30,000 to 32,767. Okay. Now I have given the kind as service and name. I will just give the name something different. We can give as node port. Okay. QCTL apply -f nodeport.yaml. Okay, so if you see here, kubectl get svc, we have my service node port. Okay, and then if you see, it has got the IP address. Okay, and then if you see the ports, here it is 80, and then here if you see here, it is 80 and then 30,012. So we can check whether it is accessible or not. So we can use two methods, like one is for using curl, and other the thing is like we can access it from website because we are using minikube. Let's see. So we have defined it on port curl, and then we can do HTTP, and then what is the IP address of this one? 13 127 174.60. Okay, so just copy that one, paste it here, and then we have to give the IP address. So what is the IP address? It is 30,012. Okay, so we have to just copy this one, just come to the instance, and under the security group you have to enable the port, edit inbound rules, add rule, paste, and then it should be accessible everywhere. Just save this one. Okay, now I have saved it. Okay, it is connection refused. Okay, let me try to port forward kubectl port forward, and then we have to give the service name. This is the service, right? And then what is the name of the service? My service node port, paste, and then we have to give the IP address. For example, here we have used different IPs, right? Let me, okay, we have used this one only, right? So 80 80 80. Okay, this one, these ports. So we can give 80 80 80. Okay, and then let's add this 80 80 also. Come to the security group, edit inbound role, add role, 80 80 from all, save. So it is saved. Okay, let's copy this one. Let me create a duplicate, paste it. Okay, okay. So issue is with my laptop. Okay, but in case if you guys try, you will be able to access. Okay, because mine my laptop is like having some permission issue because it is my office laptop. But when you guys try this one, it will work. If you say contact your IT administrator, so it is not allowing this IP. You can try with the same IP. So once we do this one, so here what we did the port forward. Okay, so connection timed out. Okay, because of that error only, that issue only. So here what will happen, when we do port forward, we are port forwarding the service. Which service? This service, and then we it will be accessible on this port number. So when you do this IP address colon this port number, you will be able to see the Nginx because we have ran the Nginx application, right? So you will be able to see that one. Okay. So this is cluster IP. In case if you have to access some application from outside, then we have to use cluster IP. And then for internal communications, we will be using sorry, cluster IP is for internal communications. And in case if you have to access it from outside, we have to use the node port. And then we have something called load balancers. Those things when we use cloud services, we will be using that thing. Okay.